Hi, everyone. I hope your week is going good and you guys are keeping up with your studying. In this video, I want to go over chapters 11 and 12. Chapter 11, it's really important that you guys really familiarize yourself with all of the equations, because it can get a little confusing, but as long as you get the gist of it, you'll understand it better. So to start, know what can be gases and which elements are not gases. So pretty much, I tried writing it on the board, but it will be backwards. So H, hydrogen, nitrogen, oxygen, fluorine, and all of group 8. Those are all your gases. Gases have weak intermolecular forces, and they're easily compressible. Another important thing you guys want to remember are the conversions. 1 ATM equals 760 torr, and also 101.3 kPa, kilopascals. Also know standard temperature and pressure, what those are. So those are 273 Kelvin or 0 Celsius and 1 ATM. Another important thing you guys want to learn is the ideal gas law. So the ideal gas law relates pressure, volume, moles, the constant, and temperature. So usually the constant will be 8.314 joules over Kelvin times mole. But your professor, I'm sure he'll tell you which one that he wants you to use. And also it depends on what the question asks for. If the question asks for, if it has ATM in the given, you're not going to use that one. You're going to use the 0.0821 liters times ATM over mole times Kelvin. So it just depends on really what the question asks. They can throw both at you on an exam. It really just depends. So yeah, the ideal gas law, that is pressure times volume equals moles of gases times N moles times the R times temperature. So that's this right here. So this can be manipulated in so many ways. They can give you, well, you always have R, but they can give you just the volume and the temperature, and you have to solve for the pressure. Or they can not give you the temperature, and they can give you everything else, and you just have to switch everything around to make sure that it fits. So this is for ideal gases only. Is this true? So ideal gases have no intermolecular forces at all, and they occupy no volume. So when the question talks about ideal gases, this is the one that you want to use, not any of the other ones. Also, this one is good because you can, you have this in your book, you can determine the gas density or the molar mass. So this molar mass, obviously from this, and density by using, changing this, because density is mass over volume, right? So you can manipulate this and find out the density just with this equation. Also, for like all the other special cases, this is what you want to know. Also, it works for this too, but you have to know that as pressure increases, temperature increases. As volume increases, temperature. Now, this is the only one that's really, this is one of them that's actually different. As the volume increases, pressure decreases. So know that, and this is shown in Whose law is this? This is shown in Boyle's law, because Boyle's law is the only one where volume and pressure are inversely related. All of the other ones, volume and moles, that's directly proportional. Temperature and volume, like we see, proportional, like that's easy. But just remember, volume and pressure are the ones that are inverse. So what else? Yes, and then this, as you guys know already, this combines all of the laws: Boyle, Avogadro's, Charles, Gay-Lussac. All of these are combined here. So I would really, focus on this, because say if you don't have a variable, you leave it out, and this will still work. So try to remember this and this. These are the two most important. Also, other important ones are Dalton's law, Henry's law, and yeah, that's all I want to talk about for chapter 11. Moving on to chapter 12. That was your chapter about intermolecular forces, and I don't know, the title's long. And also there was stuff about phase diagrams, so I want to talk about those. For that, you guys, for the intermolecular forces, the most important thing, like professors love testing you on this, know the order of the strength, which are the weakest to the strongest. That's usually always a question. So your first force is the weakest. We have the dispersion. Actually, let me show you this. Okay. So this is really good right here. So dispersion is the weakest forces, and that is because they have instantaneous dipoles. They have attractive and repulsive shifting back and forth. So they are the weakest. And you can see right here, zero attraction is only possible with ideal gases. And before I told you that, and that's the reason, because they have no intermolecular forces. That's why it's zero. So we have the ideal, then we have the dispersion. After dispersion, dipole. And this is because their attractive forces are permanent. So dispersion and dipole both have the attractive forces, but the dipole is permanent. So try to remember that. Ion dipole and hydrogen bonding, these are, see how they are kind of overlapping each other? In your book, it says the ion dipole forces are stronger when the distance between the two are smaller. So remember that, and I'm pretty sure he's not gonna, I'm pretty sure ion dipole will usually come before, most of the time, hydrogen bonding being the strongest. But also take a look at hydrogen bonds themselves, because all of these forces, intermolecular forces, they're between two atoms. So that it's not like a physical bond. Like, they're not like this. It's an attraction like this. So it's not directly connected, is what I'm trying to say. But hydrogen bonds are typically the strongest. That's what's in everything, really. Our DNA, everything. The other important thing I wanted to talk about, chapter 12, was the phase diagrams. Know the phase diagrams. Know how to read them, because phase diagrams will keep coming up in, all classes. Biochemistry, like literally organic chemistry. It keeps coming back. So try to figure them out now. That way you're a pro by the time you get to those classes. And let me just show you again what that looks like. Okay. Oh, wait. Yeah, the phase diagrams, they keep coming. So usually, this is for carbon dioxide, but usually at the top left, you will always see the solid. And then next will come liquid next to it, and then vapor. So just try to get yourself familiar with this and really master it. If you guys have any other questions about these, you know, you can always ask me during the live session that we'll have on Tuesdays. Another thing, I'm not sure which chapter it's in. Maybe it was in 11 or maybe it's in 13, but I know that your professor said last week about the Clausius Clapeyron equation. So I just wanted to talk a little bit about that too. So pretty much with this equation, this is a really good picture right here, because it shows you that this equation relates vapor pressure and temperature. So this is an exponential curve in the first graph, right? So that's not really, it's kind of hard to like make relationships between these when it's a curve. So what these two guys did, Clausius and Clapeyron, is they did the natural log of the vapor pressure, and they took 1 over temperature in order to get a straight line. Now the slope is equal to this right here, the negative HVAP over the R. The R that the same R that we used before in the gases, it's back. And so basically now you guys can make an easy relationship between vapor pressure, temperature, and the heat of vaporization. So also Chem 104, professors love making tricky questions about this and, you know, manipulating one of the variables. So it's just really important to just keep practicing questions. You know, what if I change the temperature? What if I, you know, it could be anything. Just make sure you're comfortable with putting it into your calculator and, you know, manipulating it yourself. Even if you only have a few questions from your book, change the numbers and just work it out yourself. And if you guys have any questions, like always, just message me, email me, and I'm going to send with this video just some questions to help you guys out, to test you. The best way to learn is just by reviewing and testing over and over. So good luck and see you next week.